Welcome to the lesson on scale drawings, the first lesson in the new unit on similarity. We're going to start out with something that should, I hope, be very familiar to you, and that is the feature on cell phones and tablets that gives us the ability to scale, meaning reduce or enlarge, a picture. And of course, you've all seen where you can put your fingers on the picture and either spread them apart in order to enlarge the picture or pinch them together in order to make the picture smaller. But my question for you is, how does the code for this app get written? What steps do we have to take it to the dog in order to scale the drawing? And how do we write the program to make sure that the new image is well scaled and not distorted? So in order to take a look at this, we're going to examine the same process, but on a much simpler figure, our friend the triangle. For this video, you're going to need your compass and straight edge. So if you haven't already, let's go ahead and dig those out. And we're going to start by going ahead and enlarging triangle ABC by applying a scale factor of 2. That scale factor of 2 tells us that the lengths of our segments in the new image are going to be twice as long as they were in the original. Now, in order to do this, I'm going to end up with a new triangle. I'm going to call it triangle A prime, B prime, C prime. It's going to have 3 new vertices. However, I'm going to do this in such a way that point A remains fixed. So A is going to become my A prime. But I want to go ahead and create a new side A prime, B prime that's exactly double what the original one was. So I'm going to go ahead and start out by extending side AB. And then I'm going to go ahead and do the same thing, extend side AC, because I'm going to create a new side AC prime that's double the length of the original. And in order to do that, I'm going to go ahead and grab my compass. While I'm grabbing mine, why don't you go ahead and grab yours out of your backpack or wherever you've got it hidden. And I'm going to go ahead and open up my compass and measure the distance between points A and B. I want my new side AB to be double that length. So once I have that length measured out, I'm simply going to take my compass, put the point at point B, and measure out a second segment of length AB. And now I've got 2 segments, each of which represents the distance between points A and B. So my new segment will be twice or double what the old one was. And then I'm going to go ahead and I'm going to repeat that exact same process, but this time for side AC. So again, I'll just use my compass to measure the distance between points A and C. I'll mark off a second segment of that same length. So now when I put the 2 together, my new segment is exactly 2 or double what the old one was. And now that I know where my new point B prime is and my new point C prime, now I can go ahead and grab my straight edge and simply connect my 2 vertices. And my new sides are double the old ones. So that's what my triangle looks like if I apply a scale factor of 2. Its sides are twice as big as the old ones were. In example 2, they want us to do the same thing, but now they want us to apply a scale factor that's equal to 1/2. Or in other words, they want the lengths of our new sides to be exactly half of what the old sides were. So I'm going to apply that same idea. Now I've got to go ahead and I've got to find the spot alongside AB that makes its length exactly half of what the original one was. Again, I'm going to keep my vertex A in exactly the same spot. Well, the way that I'm going to find that halfway in between point is by finding the midpoint. And the way I'm going to find a midpoint is to go ahead and construct a perpendicular bisector. So I'm going to start by constructing the perpendicular bisector of segment AB. And the only reason I really want to know the perpendicular bisector is so that I can tell where the midpoint of that segment is. Unfortunately, the software on my smart notebook isn't allowing me to do this perfectly. Hopefully yours is a little bit more accurate, or you're able to be a little bit more accurate with your compass. But there's my midpoint, which is going to become my new B prime. And I'm going to go ahead and repeat the same process for side AC. I'm going to construct the perpendicular bisector so that I'll know where the midpoint of that segment is. So I'll go ahead and construct the perpendicular bisector. And again, my only reason for constructing the perpendicular bisector was so that I could find the midpoint, because now my new side AC prime is half of what the other one was. I'll grab my straight edge and connect my new vertex C to my new vertex B. And voila, I've got a new triangle where the lengths of all three sides are exactly half of what they were in the original triangle. All right, down here they want to know what similarities and differences exist between the original figures and our scale drawings. Well, similarities, angle measures are all the same. Angle B in the old triangle has exactly the same measure as angle B in the new triangle. Likewise over here, angle B in the old triangle has exactly the same measure as angle B in the new triangle. They're exactly the same. So similarities, I'm going to say angle measures stay the same. So that would be a similarity. What differences are there? Well, clearly they're of different sizes. All right, and then they want to know how does scale factor affect the size? Well, when we had a scale factor greater than 1, it resulted in an image that was larger than our original. So I'm going to say an R, or scale factor greater than 1, results in an enlargement. Whereas the scale factor of a half, or less than 1, produces something that's smaller, or a reduction. Now, one place where scale factors are commonly used is in drawing maps, doing scale drawings, and that's what we're going to take a look at in number 2. Number 2 has to do with a map, and it says we're given this map of the school, and the scale of the map is 1 to 1,000. So what that 1 to 1,000 means is if we compare the length on the map, 1, to the length in the school, 1,000, the ratio we end up with is 1 to 1,000. Now, Mr. Woodland's classroom, it says, is exactly 65 meters away from the chem lab. It wants to know if they're 65 meters away from the chem lab in the school, how far apart will that be on the map? And it wants us to give our answer in centimeters. We're going to solve this by setting up a proportion. We're going to compare the scale that was given to us for the map to what we actually have going on in the scale or in the school. I'm going to take that ratio of 1 to 1,000. I'm going to turn it into a fraction. So I'm going to compare 1 unit on the map with 1,000 units in the school. So 1 to 1,000. And here's what I need to be careful of. If I compare the length on the map to the actual length at the school in my first ratio, then when I go to set up my second ratio, I need to make sure I make the same comparison. Map in the numerator, the distance they are apart in the school in the denominator. So what I'm given here is Mr. Woodland's distance from the chem lab in the actual school. Since that's the distance in the school, that's going to go in the denominator of my fraction. How far apart they are on the map is my numerator. So a big key idea here is whenever you're setting up proportions, be consistent. Whatever you do in the first ratio, make sure you do exactly the same in the second ratio. And then I'm sure you remember from middle school that the easiest way to solve this is going to be to go ahead and to cross multiply. So when I cross multiply going in one direction, I get 1000x. Cross multiply going in the other direction, I get 65. Divide both sides by 1000 and I get 0.065. However, this distance is given to us in meters, and we're being asked to find this distance in centimeters. Since there are 100 centimeters in each meter, I'm going to go ahead and multiply that answer by 100, and I end up with a distance on the map of 6.5 centimeters. All right, up at the top of the next page, I want you to summarize what you think are the key ideas and important understandings that you're going to need to remember from this video. And again, I want you to put that in your own words so that you'll have what you think is important. And then once you've done that, there's some sample questions down at the bottom of the page for you to try. We'll go over these when you come into class, but what I want to do is get a feel for what things you already understand well and what things we need to work on. So your job, your mission, go ahead and for tomorrow, complete the questions on page 3. All right, and that concludes our first video in this new unit on similarity, and I look forward to doing some scale drawings with you the next time you come back to class.